welcome all for Unnati Education videos. We were discussing the first, that is the second unit here in first PUC or +1, that is motion in straight line. Under that, in the last video, we have seen about acceleration, average acceleration, and I promised you to tell about velocity time graph in the next video. So in this particular video, we will see about velocity time graph. So from the point of view of examination, what you have to remember about velocity time graph? You should know the definition of velocity time graph. Usually the question will be like that. Define what is velocity time graph and draw any one type of graph. That is, question may be there. Okay, we'll see that. So what is the definition of velocity time graph? A graph representing velocity along y-axis, time along x-axis is called as velocity time graph. Okay, this definition is important. So as in the definition it is said, velocity will be along y-axis and time will be along x-axis. That will be the type of representation. So the first case you see here, for an object moving with uniform positive acceleration, that is with initial velocity equal to 0, then the graph will be like this, a straight line. It is uniform positive acceleration. Remember that. Next, for an object moving with uniform positive acceleration with initial velocity v0, it is having a particular value of velocity starting from that, then it will be uniform positive acceleration. Then the graph will change like this. It is not starting from 0, it is starting from v0 in the y-axis. Okay, then a straight line. Remember this also. Next type, for an object with uniform velocity, it is not uniform acceleration, it is uniform velocity. So it will be parallel to, the line will be parallel to x-axis and it is straight line. As velocity is not changing with time, this will be the nature of graph. Next, suppose if it is uniform negative acceleration starting from particular velocity or retardation, it will be in a reverse direction, right? That you can imagine. In a reverse direction, a straight line will be like this. Okay, that one you can draw. So these points are important in this particular part. 3 types, and uniform negative acceleration also can be asked sometimes. So what may be the nature of question? Question will be, what is velocity time graph? Then draw velocity time graph for an object moving with uniform positive acceleration, or any other type of graph will be asked for 2 or 3 marks. For 3 marks usually, 2 marks for graph and 1 mark for definition. Usually what students do is, they'll just draw the graph and they'll not define what is velocity time graph. So before answering the question, you have to read the question very carefully. That is important. Okay, that is why you'll lose mark in some cases, even though if you know the things. Yes. Next, instantaneous acceleration. So as we have seen instantaneous velocity, here we have to define instantaneous acceleration and how to find it from the graph. So definition wise, it is the acceleration at an instant, or it is the rate of change of velocity with infinitesimally small interval of time. The same definition as we had for instantaneous velocity. Here the just change is, it is acceleration, instantaneous acceleration. The equation also very similar one, A equal to limit delta t tends to 0 delta v by delta t and dv by dt. I explained in the one of the last videos about instantaneous velocity. A similar explanation can be given here. This only the difference is acceleration. The slope of tangent of velocity time graph gives instantaneous acceleration. That graph is not here. You can draw it and practice. Just take the tangent and it's a slope will give you the value of instantaneous acceleration. Okay. Yes. Up to this it is over. Now suppose if you have a graph like this, velocity time graph. Okay. This is the case of uniform velocity, isn't it? The velocity's value is v0. It is not at all changing. It's a straight line, and for some calculations I just drawn a line from this straight line towards x-axis, that is time axis, and I got a shape here. It is a rectangular shape, and suppose if I calculate the area, of this rectangle, say I will name this rectangle somewhat, say okay, A, B, C, D. If I take the area of ABCD, rectangle ABCD, this particular area inside this rectangle, what I'll get? See, AB into BC, right? Area equal to AB into BC, isn't it? AB into BC. So what is AB? AB, this length, AB, it is somewhat the value of time, isn't it? Time taken, total time taken, 0 to t, right? It was 0 initially, and then the total time taken is t. It is represented there. Suppose if I take it as t, AB will be t, okay, time, and BC, BC is this length, which is parallel to AD, BC equal to AD, right? So what you get at if you take AD is velocity, it is along velocity axis. So V0 is the uniform velocity, right? So AD is V0. So into V0, time into V0, time into velocity, right? What I got? Time into velocity, correct? So, I'll write here velocity equal to displacement by time, isn't it? Velocity equal to displacement by time. So if I have time into velocity, what I'll get, just bring this t to here, time into velocity, it will be, that is equal to x. X is displacement. So here also, in this case also, t into v0 will give you the value of displacement. So what I can conclude it as, here it is given area under the graph, area under this velocity time graph v0 t equal to displacement. So whichever the nature of the graph, suppose if it is asked what is the area under the graph, velocity time graph, if it is whatever the nature of it, the area under it will give you the value of displacement. Okay, remember this, it is very, very important. Okay, yes, and also two more points. What we have to remember in this part is that this one, slope of VT graph gives acceleration, slope of VT graph gives acceleration, and area under VT graph equal to displacement. These two things you remember. This is very similar to that what you call slope of xt graph or position time graph gives velocity, like that. Slope of vt graph gives acceleration, and this one we proved now, isn't it? Area under vt graph equal to displacement. Sometimes the second one, area under vt graph equal to displacement, may be asked for to prove. It may be asked for 3 marks. So while proving it, you can do this, do follow this method, but you have to explain the things. Okay, what is T, what is V naught, all those things you have to write, even though if you know, because the examiner who is going to evaluate you will not be knowing that you are knowing everything and you are writing it, but you have to write what are the terms. It is important. While writing derivation, explanation of terms and explanation of the picture, all those things are very important. Then you will get the full mark. Otherwise, you will lose mark in that particular category. Okay, so be careful and look at all those things and remember all those points what I have mentioned. Okay, then good luck. Thank you.